Hello everyone, in this lecture we will be going over IMO 2008 problem number 1. Here's a view of this problem. Let H be the orthocenter of our acute angle triangle ABC. I have clearly marked the point H here on this picture. H is the orthocenter. So the circle omega A centered at the midpoint of BC, in which in this case I mark the midpoint of BC as M sub A, passing through the point H, intersects the sideline BC at points A1 and A2. Similarly, we can define the midpoints define the points B1, B2, C1, and C2. Namely, you have the midpoint of segment AC, side AC, which I called it as MB. You draw the circle and you have new intersection points B1 and B2. MC is the midpoint of AB, and you draw your circle and you have these points C1 and C2 defined accordingly. Let me also name this circle as gamma C, and this circle here would be called as gamma B. And I didn't draw gamma A, but you can you have an idea that gamma A would be centered at point M sub A. So we would like to show that those 6 points are actually concyclic points. First of all, I would like to point out that so these two circles, omega C, gamma C and gamma B, they intersect at point H, and the other intersection point here would be point X. And so first of all, I would like to start by showing that B1, B2, C1, and C2, they all are concyclic. So in the first step, I will show that B1, B2, C1, C2 are cyclic points or concyclic points. For that, I will employ the same methodology I used in the previous question. So I have this circle, and I will focus on the circumcircle of triangle C1, C2, B1. Consider the circumcircle of B1, C1, C2, and I will show that equivalently, I will show that B2 in fact lies on that circle, B1, C1, C2. Now that new circle, let's call it gamma. Let's call it omega, that green circle. So first of all, notice that the radical axis between omega and gamma C would be C1, C2. So the radical axis of gamma C and omega is simply equal to C1, C2. In a similar way, the radical axis of gamma B and gamma C is in fact equal to the line between and those two intersection points X and H. So therefore it would be XH. So let me make a side note. So notice that this radical axis here between gamma B and gamma C, I claim that that radical axis would go through point A. So why would that be? Because the line segment joining the centers of these two circles, gamma B and gamma C, namely these are the midpoints of their respective sides. So therefore MB, MC, notice, is parallel to BC. So MB, MC is simply the midline of triangle ABC. As such, it is parallel. But then we know that the radical axis would be perpendicular to this line segment joining the centers of these two circles. So therefore XH is perpendicular to that to MBMC, or if you will, it is perpendicular to BC. But now you have a line which is perpendicular to BC. It goes through the orthocenter. Therefore, it must go through point A as well. So in my side note, I say that A is contained on the line XH. So that's a very important note for us. Okay, now going back to my explanation. So the radical axis of omega C and gamma C and omega goes through, is the line C1, C2. In a similar way, the radical axis of gamma B and gamma C is XH, but I know XH goes through point A. So therefore, the intersection of these two radical axes will give me my radical center. So therefore, the radical center is nothing but point A. So now that I know point A is the radical center, the radical axis of circles gamma B and omega would go through the points. First of all, it would go through point B1 for sure, goes through B1 for sure, and the radical center A. So there is this immediately implies that because now I know that the second intersection of the circle gamma B and omega will therefore have to be B2, because we want our radical axis of those two circles omega and gamma B to be the line AC. It has to go through those points B1 and A. So therefore it must be that the case that the circumcircle of B1, C1 and C2 goes through B2. Therefore we have proven that B1, B2, C1 and C2 are actually cyclic points. Now my next question would be, where is the center of that circle, that green circle omega? Well, it would be on the perpendicular bisector of this chord C1, C2 and the perpendicular bisector of the chord B1, B2. The intersection of these two perpendicular bisectors, which is, as you all can imagine, the circumcenter of our triangle O. The circumcenter of our triangle O would be the perpendicular bisectors of these two chords. Now that I know the center of this circle, I know these 4 points are concyclic, so therefore I can establish that B10 is in fact equal to B20, which is equal to C10, and it's also equal to C20. Let me write those down here. Actually, let me slide this page here. So far I know that that B10 is actually equal to B20, which in turn is equal to C10 and C20 as well. So finally I can make a similar analogous line of reasoning and show that in fact points A1, A2, B1 and B2 are also concyclic. But if these points are concyclic, it means that B10 is also equal to A10, and at the same time it is equal to A20 as well. So therefore we have shown that this actually proves that these 6 points A1, A2, B1, B2, C1, C2 are all concyclic points, and the center of the circle would be the circumcenter of our triangle. So that solves this problem. Hope to see you in our next video.